talked about graphing quadratics. Now we're going to talk about writing quadratics. All right. So these are the steps in order to do so. You have to be able to recognize the difference between vertex and standard form at this point to be able to do this process. That's like a prerequisite skill to be able to do it. And remember that f of x and y are interchangeable, so you'll see me using those interchangeably throughout the notes. Step 1 is to identify your vertex, whether it be a table, a graph, whatever they give you, and then choose a point, any other point. So you're always working with a vertex and another point on the graph. The vertex has to be the vertex, but the other point you choose can be any point on the graph or in the table. It does not matter which one you choose, the answer will be the same. You'll notice that I will try to pick values that are the easiest to work with mathematically or algebraically, okay? Then you're going to solve for A, and then you're going to rewrite your quadratic in vertex form using the information provided. All right. So, number 1, we're going to go from factored form to standard form. So, you need the notes. Oh, I already gave you some. Okay, good. So step 1 to do this is you're going to need to multiply these two binomials together, okay? So, first thing I'm going to do is I'm going to rewrite this f of x equals 1/2. Now, I'm not going to work with the 1/2 yet. I'm going to wait until I multiply everything together, and then I'm going to distribute the 1/2. So we're going to use FOIL here, first times first, which is x squared, outer times outer, which is 8x, inner times inner, which is 6x, and then last times last, which is 48. Now within the parentheses or brackets, whatever you used, you're going to now combine like terms. So as you can see, these are like terms. What's 8x plus 6x? 14x. Good. So now we're at this stage, and now we're ready to distribute that 1/2 onto everything. So I'm going to distribute the 1/2 onto these three terms. That's going to give me f of x equals 1/2 x squared plus 7x plus 24. So does anyone have any questions about how I got that final answer? Yes?
Why did you use brackets on the
You don't have to. I just sometimes, when I alternate sometimes to make sure you see the difference. But you can use either one, it doesn't matter. It's not like the domain and range stuff where you have to use one or the other. Any other questions? All right, cool. Ready to try another problem?
Yes.
So, sometimes you're going to be given a table and you have to work with a table. So let me explain what to look for in the table. In the table, you want to identify the vertex. So the way we can identify the vertex is look for the pattern. As you can see, these zeros are repeating, and then the 15s are repeating, which indicates symmetry on the f of x side. So that value in the middle of the symmetry is going to be your vertex. Does everybody see how I was able to identify it using the symmetry rule? Okay. Now that we've identified our vertex, we're going to just write out the vertex, and that's going to be 0, -5. And you're going to label it h and k. That's always what the vertex is. Now at this point, you're going to pick one other point in the table, any other point. I'm going to choose 1, 0. And the reason I pick 1, 0 is I know it's going to be the easiest to work with. But if you pick any point, you'll still get the same answer I get. Okay? So now that we've identified the vertex and a point, we're going to write out the general vertex form of a quadratic equation, which looks like this. Okay, so that's from the front of your notes. That's the general form. Okay? Now with this form, we're going to plug in for h, we're going to plug in for k, we're going to plug in for the x, I'm lagging, sorry, and then we're going to plug in for the y. So you're going to plug in each of those items into that equation. So that's going to be 0 equals a times 1 minus 0 squared minus 5. So everybody see what I did there? I just plugged in for each of those items. And now your goal is to simplify and solve for a. So 1 minus 0 is? 1 squared is? What's a times 1? 1a, or just,
A.
so isn't this just simplified to 0 equals a minus 5? And then how can I solve for a at the end?
Plus 5.
Good, so a is equal to 5. So everybody see how we got a equals 5. That's the only piece of information I didn't know about my quadratic. So in order to write a quadratic in vertex form, you have to know a, h, and k. Now do we now know all those pieces of information?
Yeah.
Now we're ready to write the vertex form. So what I sometimes will do, I'm just going to write it out in each individual step this first time around so that nobody gets lost. I'm just writing out the standard vertex form again, or should I say general form. And now I'm just going to plug in for A, H, and K. And that will give me what my actual equation is. So we used X and Y as a tool to help us find A, but we don't end up using them in the end result. So my answer is Y equals 5 parenthesis X minus 0 squared minus 5. So I plugged in for A, H, and K as you want to at the end. And now, do we have to write X minus 0? Is that necessary? No, we can just write X squared, right? So this is technically vertex form, right? So we can write that in as our vertex form. So for vertex form, we would just say Y equals 5 parenthesis X minus 0 squared minus 5. Now, we don't need to FOIL this out because this is really just X squared, isn't it? So I can write my standard form as Y equals 5 X squared minus 5. So I just took out that 0 that was unnecessary there because I didn't need it. And now you can just list out all of your key features, the vertex of course. If your A value is positive, that means that you have a minimum every time, and it occurs at -5. And y-intercept. Two ways to find the y-intercept. You can plug in 0 for x into either of these versions, or even easier is in standard form, the c value is your y-intercept. Okay, the c value is your y-intercept only for standard form. Okay, yes.
The max or min at -5, is it always going to be -5 or is it going to be the a value with the flip side?
It's whatever the y-coordinate of the vertex is. And then x-intercepts. We're not at the stage where you're able to mathematically find these. We will eventually learn that. But for today, you're either going to be estimating off a graph or you're going to look in the table. X-intercepts occur where the f of x or y value is 0. So we have one at -1, 0 and 1, 0. They always occur when y is 0. Now we're going to identify our transformations. So since A was positive, we do not have an x-axis reflection, but we do have a vertical stretch of 5, right? We also have a shift down, right? Down 5 units. So does everyone see how those are our two transformations that occurred here? Why did we not go left or right? Because h was 0. So do we have any questions about number 1? All right, number 2. So in order to do number 2, I'll make this a little bit bigger so you guys can kind of see what's happening here. First thing you want to do is you want to identify the vertex, and we've identified that as 5, 3. And we know that this is my h and k, okay? Next thing you want to do is you want to pick any other point on the quadratic, any other point. Now, would it be wise to pick one that's not on a grid? No, we're going to pick one that's on a grid. I see we have one here at 6, 4. You could also pick the one at 4, 4 if you wanted to, okay? So pick one that's a nice, solid number. Don't pick a decimal. Can if you want, but I wouldn't recommend it. And we're going to call that x and y. Now we're going to use our general form for vertex, which is this formula. And in that formula, we're going to plug in for x, y, h, and k. x and y are the point that we picked, h and k are the vertex. So it's going to be 4 equals a times x minus h squared plus k. So everybody see where I got those numbers from. Now we're just going to simplify and solve for a. 4 equals, this is 1 squared, which is just 1. 1 times a is just a, which means a equals what? 1. So now when you go to write your vertex form, you take this formula right here, and you plug in for a, h, and k and rewrite it. Only a, h, and k. You don't plug in for x and y. A, h, and k. And that would be my vertex form. Now technically you don't need to write that 1 out front. I just want to make sure you understood where it came from and that we did actually put the 1 in there. But you don't have to write that. So here's the one problem now. This is not going to cancel out because it's a minus 5. So we're going to now figure out how we go from vertex form to standard form. So here's step 1 on how we do that. So first thing you're going to do is you're going to rewrite the equation, but instead of writing the x minus 5 squared, you're going to write it twice. And then you have that a value out front. Now sometimes the a value will be like a 2 or a 3 or whatever. Then you'd have to distribute it, but since it's just a 1, it's going to make our lives a little bit easier. Okay? Now here's how you get to standard form. You're going to multiply these together right here first and foremost. Okay? So FOIL. So that's going to be x squared minus 5x minus 5x plus 25 plus 3. Now we have to distribute that a out, but since the a is just 1, is it going to change anything? No. So since that's the case, we have one less step to worry about. Now I can just combine like terms and bring down that 3 on the outside. And then combine like terms one more time. And I get y equals x squared minus 10x plus 28. So you want to make sure it looks like standard form. Standard form should be ax squared plus bx plus c, which it is. And then whatever you get for c is your y-intercept. 0, comma, whatever that value is. In this case, it's 28. If you don't have that, you could also find the y-intercept by plugging in 0 into either form. So as you can see, we have a minimum at 3. And now we're going to identify our transformations. When you go to identify transformations, you always use vertex form. So it looks like we went right 5 units and then up 3 units, right? So does anyone have any questions about how I identified the transformations? Yes?
How do you know his maximum and min?
If the a value is positive, it's always a min. If the a value is negative, it's always a max. Because it will be like, the graph will be going down, so it has to be the highest versus going up. And you had a question?
Yeah, how did you know the y-intercept is 10?
That's a rule that the c value is always whatever the y-intercept is, because obviously you can't see it on the graph. But if you don't feel like that's a good enough reason, intercepts always occur when the other variable is 0. So you can plug 0 in for x into either one of those equations and simplify, and you would also get 28. Does that make a little more sense? All right, does anyone have any other questions for me before we move on to the next question? Okay. So the next one we're looking at is this one here. Now mine got cut off for some reason when I screenshot it, so you guys will have to help me out at the end, but for now it's pretty straightforward. So I'm going to zoom in here and get a better look at it, because this one's a little bit hard to identify a point. I almost made this mistake earlier. It actually has a y-intercept of 0, 9. It looks like it's 8, but it's actually a 9. Okay? So this right here is my h and k. And this over here is my x and my y. Now you could use another point on the graph as well, but I'm just going to use the y-intercept. So Now that we've identified a point and the vertex, we're ready to plug into the form, which is y equals a parenthesis x minus h squared plus k. And then we're just going to plug in. We got 9 equals a times 0 minus 1 squared plus 12. So I just plugged in for h, k, x, and y. Now I'm going to solve for a, so this gives me 9 equals, this becomes a 1, a plus 12, and then I subtract 12 on both sides, I get a equals negative 3. Now to write vertex form, I write y equals whatever my a value is, times x minus whatever my h value is, plus k. Now something I just want to make sure you're aware of in case it comes up. What if my h had been a negative? What would happen when I put it into the formula? It becomes positive. Just keep in mind the h is always going to flip. And then we're at this stage where we need to identify standard form. So to find standard form, you're going to rewrite your equation, but you're going to write your binomials out like this. And then from here, you're going to multiply these together first. So that gives me negative 3 parenthesis x squared minus x plus 1 plus 12. So that came from here. And then I'm just going to combine like terms. Like that. So that was just these being combined. And now I can distribute that negative 3 onto all three terms. You done?
Yeah.
Okay. Thank you. And then the notes are right there, those white ones. And then from here you can just combine like terms. And you should end up with that. That's your standard form. So y equals negative 3x squared plus 6x plus 9. So we've already determined that our vertex is 112. That's a maximum at 12. The y-intercept is at 0, 9. And then what are the x-intercepts? I think it's negative 1 and 3, right? I can't see mine on my graph. There is a way to find them algebraically, but we haven't learned that yet, so I don't want to get into that today. And now as for our transformations, we have an x-axis reflection. I'm writing intercept for some reason. We have a vertical stretch of 3. And then we also went right 1 up 12. So does anyone have any questions about that before we move on? Okay.